I'm Rob Reed, Technical Evangelist at Cockroach Labs, and today I'd like to talk to you about running mission-critical applications in Kubernetes on top of CockroachDB. So it all makes sense to start with distributed SQL. And fundamentally, CockroachDB is a distributed SQL database. That means it brings together a lot of the different database paradigms that we've seen historically. For example, that means the reliability, consistency, and familiarity of databases like Postgres, MySQL, the traditional relational database management systems, the RDBMSs, together with the NoSQL databases, the scalability, flexibility, and resilience of those databases. Historically, those two database paradigms haven't overlapped if we're talking about a Venn diagram, but that's what CockroachDB brings to the table. Cockroach is a distributed relational database, and it provides everything you'd want and expect from that kind of database. It provides referential integrity, normalization, and the like. It also provides serialization by default, so you're guaranteed that whatever you write into the database, all of your consumers of that database will see out. And by adding nodes to it, you horizontally scale, not just for reads, but also for writes. Every node in CockroachDB can handle reads and writes, so scaling is quite a seamless process. And there's no master or primary node in CockroachDB, as you see with a lot of databases. So once scaled, CockroachDB will rebalance the data across the nodes. Essentially, you can think of CockroachDB as being a monolithic key value store, which looks and feels just like Postgres. We chop up the data in each table, and then those chunks are called ranges, and we distribute those ranges to different nodes within the cluster for resilience and scalability. And scaling might be required across regions. In this example, we're scaling across California, Ohio, and North Virginia. You might also need to scale across clouds. CockroachDB has you covered there as well. It doesn't really matter. CockroachDB ultimately boils down to a single binary that we can either host for you in a managed service, or you can run self-hosted yourself. So it also, being a horizontally scalable database with no master nodes, it's really good at surviving multiple kinds of outage scenarios, up to including regional outages and even whole entire cloud outages, if that's your fancy. So, for example, users in this demo, in this slide, they might have been talking to region 3, North Virginia, but let's say that whole region went out, and now we're in the realm of some of the most severe outages in history. The worst you're likely to see in a Cockroach setup, perhaps, is a missing in-flight request that can be retried, but probably more likely, the worst case scenario is you're going to see slightly increased latencies until that region comes back online and consumers near that region can talk to their closest region. Scaling might also be required across continents. You can harness different database topology patterns in order to get great performance no matter where your users are. So, for example, you can lock data to specific regions, which I'll cover in a minute, by using the regional by row topology. That's great for providing low read and write latencies to users near that region. You can also use the global tables topology pattern, which gives fast, low latency reads to everyone, regardless of where they are. And we've got other products as well. I'm going to talk about serverless at the moment because we run that on Kubernetes. We run dedicated, another offering on Kubernetes as well, but I'll talk about serverless. And it's a great one to try if you're looking at dipping your toes into the world of distributed SQL. So in this example, we see one entry point, a separation of SQL and storage, the isolation between tenant pods, a warm pool of unassigned pods that are ready to be associated to a tenant. And it's also running across multiple AZs, although you're more likely to be running it across multi-region. That's exactly what we tend to do. And let's just focus on tenant 1 for the time being. I see there's a raised hand. Paul, do you have a question?
That was the 1 minute warning.
Oh my word. So what I'll do, I'll blaze through this. So if tenant 1 needs more space, more capacity, we bring in a pod from the hot one. If one that need goes away, we remove it and it goes back into the hot pod pool. If the overnight usage for tenant 1 completely drops off, so do the pods, and it comes back online when they do. So we've got an example of a database running a global application. This took about 10 minutes to create. And I'm running in the UK with low latency and with Great British Pound, GBP. I'm hitting a island database and my application is running in London. If I then hit a German user would experience slightly higher latency. They're still talking to the island database, and they see everything in euros. United States, high latency, but you're not going to talk to a United States database from the UK. So to simulate a United States user, I flick my VPN over and I'm now getting really low latency. And it doesn't matter what language you're talking in. The localization table is completely global. So users, regardless of their language, can get a great experience from the app. And this is the entire database definition for that whole app. I create a database, I enable super regions, and into those super regions, so I'm pinning data to the US and the EU. I create a table called product. And whenever I see a market of Germany or France, I ask for that data to go to the EU Central Frankfurt node. And then the internationalization table is global. And I enable these with just one single line of text. So it's really easy to get a fast user experience and a global database for your users. And we can run on Kubernetes just as easily.